Welcome to the 10th lecture of our second chapter in our comprehensive machine learning, data science, and AI course. Now, here we want to discuss about operator precedence in Python. So, operator precedence means sometimes you will have to make choice whether plus operator or that is addition operator will be applied first or whether exponentiation, that is this 2 times asterisk, that is actually a number raised to another number, that will be applied first. So this table actually explains the operator precedence. Then one is highest precedent is exponentiation. So that means first you always do exponentiation. Next is unary positive, unary negative, or bitwise negation. So bitwise negation means that not operator or tilde symbol which we talked about. Or these are just unary positive or negative numbers, that is +5 or -5 like that. Okay, they are ordinary integers applied to ordinary integers. Then multiplication, division, floor division, that we have seen integer division, 2 times division symbol is written, or modulus. They have slightly lower precedence than the unary operator. Then this addition subtraction, they have even lower precedence. Then this bitwise left shift and right shift, they have less precedence than all these above it. Then this bitwise AND, they have less precedence than all above it. Bitwise XOR have less precedence than all these. Bitwise OR has less precedence than of up to this, all up to this exponentiation to bitwise XOR. Then comparison operator. Now this bitwise thing, as I already said, that you can even forget about this because most of the times 99.99%, that means that if you work on 1,000 projects as a data scientist, perhaps in one project you will be required to use this, unless of course you are going for that specialization, embedded machine learning. That is a different thing, but you will not be attending this this basic course, no, because you have already done that basic course. So for the basic or even mid level or even advanced data science, you will perhaps not require this. So that means you can forget. Then what remains is exponentiation, then positive or negative, unary positive negative. Even this not also you can forget, it is a bitwise operator. Then multiplication, division, addition, subtraction. Then straight away you go here, comparison operator. These are all our familiar operator. Equals, equals, not equals, then less than or equal to, greater than or equal to, is and is not. Okay, we have seen that the is and is not are used to check if the two variables have same memory locations or not. Okay, if those who are not clear, they can see the lecture before, I think not previous one, but the lecture previous to the previous one. Okay, now then this boolean not and all these also will be required. Now, it looks that this how we will remember and all this thing and all that, but there is no need to panic about this thing. One can easily remember this by one simple rule, and that rule is here. The rule says that it is called PEDMAS. Only PEDMAS is as such enough to remember, but if you want to remember even the bitwise operator also, then you can remember PEDMAS, bit, com, and log. Now if you just remember this abbreviation, then you are clear. Forget about this P first, but E stands for exponentiation, M stands for multiplication, it also, then D stands for division, A stands for addition, S stands for subtraction. So that entire table now you are seeing that it is making sense. Bitwise, all bitwise operators. Now among them, what is internally precedence, that you have to remember. But as I said, forget about that at present. Just keep this lecture as a ready reference, or just this diagram as a ready reference, so that whenever you require, you can apply that knowledge. Then comparison operator. So comparison operator are here. These are all comparison. Then logical operator. So these are all logical operator. That is not and or. That is boolean not, boolean and boolean or. Okay. So this simple rule makes it easy to remember. Let us take some examples. It will become even more clearer. Say suppose it is written result is equal to 10 plus 5 asterisk 2. Asterisk is for multiplication. Now the question is, one person will say I want to do 10 plus 5 first, and then I will multiply by 2. So answer will be 30 because 10 plus 5 15. But another person will say no, I want to do 5 into 2 plus 5 multiplied by 2 first. So 10, and then I want to do this addition. The question is who is correct? Then you have to look at this rule. So multiplication has higher precedence than addition. So multiplication should be done first. So 5 multiplied by 2 is done first, 10, and then 10, and then another 10 is added to it. So result should be 20, and the result is 20. Okay. So this is the explanation for that. Okay. Now then result equals, this is second example we are taking, 2 plus 3 exponentiation 2. Now here as such exponentiation, that means the power that has the highest precedence, but that PEDMAS, I said forget about this P, now that P comes into picture, that P stands for parenthesis. So parenthesis has the highest precedence of all these. So parenthesis is actually not an operator, but you can say that parenthesis sits on the top of this table. Okay, so parenthesis is used to override the precedence of any other operator. So whenever something is put in a simple parenthesis, then you have to do that thing first always, and then thereafter apply the rules as per this table. So as per this table, exponentiation comes very first. So do that very first. But before that, you have to apply parenthesis. So 2 plus 3, 5, and 5 square. So 5 square is 25. Okay. So then this is 25. This is how we can do that. Now here result equals next example 10 greater than 5 and 8 less than 5. So here there are multiple operators. This greater than and less than, they are comparison operators, and this and they are logical or Boolean operators. Again, you have to, there are no parentheses here. There is no parenthesis. So that means that issue is not arising here. So you have to start exponentiation and all that, add mass. So in that, first you will do this. Okay, here the choice is only between comparison and Boolean. So let us see, comparison comes first or Boolean comes first. So comparison has higher precedence, greater than or less than, they have higher precedence, while Boolean operator have lower precedence. That means comparison is done first. So 10 greater than 5, obviously it is a true statement, and 8 less than 5, it is also a true statement. So true and true. So we have seen that AND operator is a bit strict operator. It requires both sides on its both operands on its two sides to be true. But here both are true, so the answer will be true. Okay. And answer is true. Okay. So this is its explanation, which I already gave. Now here 10 plus 2, this is bitwise 1. Okay, so 2 bitwise 1. Now bitwise operator have lowest precedence normally, but okay, at least they have lower than the addition subtraction. So that means that first this 10 plus 2 will be done, and then whole thing will be subjected to bitwise 1. So this expression involves addition and bitwise left shift. Bitwise operator have lower precedence than addition. So first 10 plus 2 will become 12. Then it will be converted into binary, that we know internally, because this bitwise operator can only work on a binary number, and then it shifts the bits of 12 one place to the left, which is equivalent to multiplying by 2. When you shift one place to the left any binary number, then in decimal the number will be multiplied by 2. Okay, so then 12 multiplied by 2 will be 24. Let us check if it is there or not. So 24. But the key point as far as precedence is concerned is whether you do this left shift first and then add this 10 plus whatever number is obtained by left shifting, or whether you do 10 plus 2 first and then 12 is obtained and then you do this left shift. Okay, so operator precedence of plus is higher than bitwise left, therefore you will do 10 plus 2 first and 12 will be obtained, and then you will do left shift by 1. Left shift by 1 is always multiplying by 2 in the decimal system. So 12 will be multiplied by, this 12 will be multiplied by 2. So it will be 24. Okay, and we checked also. Now here x is equal to suppose none, then the result x or 5. Now or is a slightly special type of operator. It is a logical operator, that is true, but it is also called short circuit operator. Okay, what is the meaning that we are going to see in this example? So here there is none. If it is ordinary some number, say this number is 5, means it has 5, or any number which has evaluated as non-zero, that is considered as true. And this number, if it would be some other number, say 1, then that is also true. So true or true, then answer would be true. Even if this would be 0, then that would be false, but false or true. Then or is slightly lenient operator, which know that any one side on it should become true, then the result will be true. But the problem here is that this is neither 0 nor 1, but it is a kind of special value, none. None does not belong to the set of integer or any set of numbers. Okay, so when the left side is falsy, falsy means what? It can have either value none, or it can have value false, or it can have value 0. Okay, then the OR operator simply stops evaluating here. If these options are there, none, false or 0, then it will straight away start giving a value 0, and then this, that means this is 0 and 0 or 5. So the expression will evaluate to 5. Okay, so that you can check 0 or 5. So 5. So logical operator OR is a short circuit operator that returns the first true the value or the last evaluated expression. So first true the value, here x can be none, then it is a falsy value. So that it, the result will not return that. Okay, here I can put false also, this word false clearly. Then also it will not return that. It will wait until some true value appears in its evaluation. If I can put 0 also, 0 is equal to false. For all practical purpose, you should remember that Python internally does not store true and false words, but true is stored as 1 and false is stored as 0. So whenever you see true, you should remember one only, and whenever you see false, you should remember zero only. So whenever false or zero is seen or none is seen, they are called falsy value. That means this thing is falsy. Then it waits until what is the next thing, and if the next thing is truly, then it will evaluate the whole result as the last evaluated expression or first truly value. Okay, and if both are suppose false, this is also false and this is also false, then obviously the result will also be false or zero. Okay, but here it is obtained as 5. What I am saying is that here you can write x or false. Sorry. Okay, now let us check. Now this is evaluated as false and this is also evaluating as false. So there is no truly value. Interestingly, what it does false because both sides are falsely. So truly value is not there. Then the answer is also false. Okay, let me make it back to original.